guys, we're Tuesdays to the homework help video, page 460. These numbers right here, let's jump right into this. For numbers 9 through 16, the directions say to state whether or not the expression is a polynomial. So number 9, no, this is not a polynomial. Now, remember, in order to have a polynomial, you have to have terms like this. You have to have, your variables have to be the same, one variable in each term, or actually no variables in each term is fine also. But you cannot have negative exponents. Now, you can have, listen to me carefully, please, you can have negative exponents with the number, because 2 to the negative 1 is just 1/2 x. 2 to the negative 1 is just 1/2, remember? 2 to the negative 1, you bring it down to the bottom, and it becomes 2 to the positive 1, okay? But you cannot have negative exponents with your variables. This is a variable. That's a negative exponent. No, this is not a polynomial. Number 10, definitely, yes, that's a polynomial. I mean, nothing weird about this at all. We have our expression. It's terms. We have our terms here. This term has a variable. The power is 1. This term does not have a variable, which is fine. That's like having x to the 0 power, which is fine. And your coefficient here is a real number. It's a rational number. And this number here is a rational number. So we're good. Number 11. No, this is not a polynomial. No. Very simply why? I mean, very simply, let me show you why. If I tried to simplify this, I could not. There's really nothing I can do with this. So really what I have, to be honest with you, is 6x squared plus 1. All of that to the what power? Do you remember? Remember, when you have a square root, it's the same thing as running with a 1/2 power. This entire expression right here is to the 1 power. And what number is here, even though you can't see it? A 2. Guys, that's not a polynomial. Look, a polynomial expression, or a polynomial, is just a list of terms, not under a radical, just a list of terms that fit certain criteria that I've given you. Under a radical is not correct. No, this is not a polynomial. Number 12, well, we have a list of terms, at least one term. That's my term. If you want to, I can go like this. Nothing wrong with that. Okay? So, if you want to write it x to the 0, that's fine. There's my variable. There's my exponent. Everything's fine there. My number is a rational number. Everything's good, guys. Yes, this is definitely a polynomial. Number 13, no, definitely not. Look, this is not a list of terms. This is a fraction, okay? A polynomial is a list of at least one term. And that's broken right there. This is not a list of terms. That is a rational or fractional algebraic expression, okay? It is not a polynomial. No, that is not a list of terms. Definitely not. Yes, we have a list of terms. That's true. But your exponent must be positive, and it must be a rational number. It must be positive, and it must be a rational number. That's a variable. That's not even a number. That's a variable. No, this is not a polynomial function. No. Don't make this harder than it is. A polynomial is just a list of terms. That's all it is. A list of terms. Now, when you look at this one here, you're probably saying to yourself, no, hold on a second. It's a list of terms, so I've got a second power. Well, guys, if you go back and listen to what I said on number 11, I said to you, you might not have heard me say this, but you can back up the video and listen. I said somewhere when I was doing number 11 here, I said, if you simplified this, you would get this. Which really is not a simplification, it's just rewriting it. So in other words, you really can't simplify this, so we have to leave it like it is. So no, it's not a polynomial. But if you can simplify it like I tried to do right here, then simplify it. Well, I can simplify this. X minus 2 to the second power means x minus 2 written how many times? Twice. X times x. X times negative 2. Negative 2 times x. Negative 2 times negative 2. And so we're left with, combine these two terms here, negative 2, negative 2, you owe me $2. You owe me $2 more, negative 4. There we go. This expression expands to this expression. Is that a polynomial? My goodness, yes, most definitely. So if this is a polynomial, then so is this, because they're equal. How do I know this is a polynomial? Well, first of all, do I have a list of terms? Yes. Do I have the same variable with all the terms or no variable? Yes. X, and no variable. Are my exponents of my variables rational numbers in positive? Yes, they are. Are my coefficients rational? Yep. 1, negative 4, 4, yep. All of them are rational. We're good. That is definitely a polynomial expression. No, this would not be. I mean, look, it's not a list of terms. You've got a logarithmic function. That is not a polynomial. I mean, it fails right away, guys. You don't have a list of terms. It's a logarithmic expression. No, it is not a polynomial expression. All right, number 17. 17 through 22, the directions say to write the polynomial in standard form, then give its degree. Okay, find your variable and write the highest exponent first. That term comes first. Find your next highest exponent of a variable. 1, that term comes next. And your constant term always goes last. And there we go. I've written it in standard form. Now they want us to state the degree. This is what we call a second degree. A second degree polynomial. You do not need to know this, but just to get used to seeing this, a second degree is also called a quadratic. You do not need to know that yet, but get used to seeing that a second degree is also called a quadratic. But here's the answer right here. Standard form, second degree, number 18. Alright, let's write it in standard form. Find your variable, x, find the highest exponent, and that comes first. This comes second. Now, some books are going to want you to eliminate, to try to do different things with the fractions. I'm not going to worry about that. This is definitely sufficient. This is standard form. Highest exponent first, then working your way down to the lowest exponent. Now, that's standard form. What degree is it? Highest exponent 2, so it's a second degree. Second degrees are also called quadratics. Alright, number 19. Okay, let's find your variable, x. Find the highest exponent of a variable, 3. Find your next highest exponent of a variable, x squared. And then your constant term goes last. There we go. Alright. So thus, this is written in standard form. We're finished with that. Now, what's your highest exponent of a variable? 3. So we call this a third degree. And you do not need to know this yet, but get used to seeing this. Excuse me. Third degrees are also called cubic polynomials. Cubic, okay? So this is called a third degree. That's what you need to know. And eventually you'll learn this. It's called a cubic polynomial, alright? Number 20. Okay, find your variable. Here it is. Highest exponent is 3, so that comes first. Next highest exponent is 2, so this comes next. Next highest exponent is 1, that comes next. And your constant term always comes last. There, that's standard form. Piece of cake, finished. Now, what is your highest exponent? 3, so this is a third degree. You do need to know that, okay? Now this next part here, you don't have to know yet. But get used to seeing this. We also call a third degree a cubic polynomial. Cubic. Alright, 21. Find your variable. It's x. What's the highest exponent? 3. So that comes first. Next highest exponent, 2. That comes next. Constant term comes last. There we go. You've written it in standard form. Now, find your highest exponent. There it is. It's 3. So this is a third degree. Third degree. Okay. Also, We're going to learn this later. We get used to saying this. We call that a cubic polynomial. Cubic. Alright, number 22. It's already written in standard form for you. Your highest exponent is first, then your 2, then your 9, then your x, then your 18, so we're good. This is already written in standard form. Your highest exponent is 3, so we call this a third degree polynomial, and third degrees are also called cubics. By the way, you do not need to know this, but a fourth degree, get used to seeing this, they're called quartics. That's as high as we go. If it's a fifth degree, we just call it a fifth degree. If it's a sixth degree, we just call it a sixth degree, etc., etc. So, the third degree, cubic. Okay? Alright, moving on. Numbers 23 through 29, the directions say to perform the indicated operation. When I look at this, I notice I'm adding two polynomials, okay? I'm not multiplying. So there's a positive sign in front of this parentheses. Multiply it through, nothing changes. There's a positive sign here, multiply it through, nothing changes. And now we combine like terms, x squared, positive 6, positive 5. Constant term here, positive 1, negative 4, you have $1. You owe me 4, you pay off part of your debt, you still owe $3, negative 3. There we go. Number 25. Okay, the two parentheses are not multiplying. We're just going to simplify. There's a positive sign here, so we multiply the positive sign through. Nothing changes. There's a negative sign here. Distribute or multiply the negative sign through, and all of the signs change on the inside. Positive becomes negative. Positive becomes negative. Negative becomes positive. Now combine like terms. X squared, they cancel out. Positive and negative, they cancel out. X terms, negative 3x, negative 1x, negative 3, negative 1, negative 4. Positive 3, positive 1, positive 4. And there we go. Okay? That is your polynomial simplified. 27. Okay, the two parentheses are not multiplying, so we're just going to simplify. There's a positive sign here, so nothing changes inside of the parentheses. There's a negative sign here, so all the signs change. Positive 20 becomes negative 20. Positive becomes negative. Negative becomes positive. Negative becomes positive. And there we go, let's combine. Here's an x cubed and an x cubed. Positive 8, negative 20, that's a negative 12. You owe me 20, you pay off 8. You owe me $12. Here's an x squared term. I see no other x squared terms up here, so bring it down. Here's an x term. I see no other x terms up here, bring it down. Here's a constant term and a constant term. Negative 1, positive 5, that's a positive 4, you owe me $1. You pay off your debt, you still have $4 to the good. There it is. Number 29. Notice they are not multiplying on 29. So if they're not multiplying, we're just going to go ahead and get rid of the parentheses and simplify. There's a positive sign here, so nothing changes on the inside. There's a positive sign here, so nothing changes on the inside. Positive 2x, negative 20. Okay, combine like terms. Here's an x squared. I see no other x squareds, so bring it down. Here's an x term and an x term. Negative 15, positive 2. Combine those, you get a negative 13. Negative 13x, of course, and now those are gone. Constant term, combine those, negative 4. There's your polynomial. Really simple. Okay, number 37. Here the x is right next to the parentheses, so we are multiplying. We are taking this x and we're multiplying it through each term. X times x squared, don't forget your x is a power of 1. X times x squared, x cubed. X times 9x, positive times a positive is positive. 9x 9x squared. There's a 1 here, and there's a 1 here, 9x squared. X times negative 5, positive times a negative is negative. X times 5 is 5x. Finished. How do I know I'm done? There's no like terms to combine. I have 1x cubed, 1x squared, and 1x term. There are no like terms to combine. Alright, number 41. Okay, in the last problem we had one term to multiply through. Here we have a binomial, or a two-termer. We have a binomial times a binomial. Okay, so let's take a look at this. Notice there's no positive or negative sign between the parentheses like we were doing earlier up here. Okay, so these two parentheses are multiplying each other. So you take the first term and multiply it through the other parentheses like this. It's like x times x minus 4. You're taking this times this. Alright. X times x is x squared. X times negative 4. Positive times the negative is negative. X times 4 is 4x. Now we're going to take a 2, but not just a 2. A negative 2. Watch your signs. We're going to take a negative 2 and we're going to multiply it through a negative times a positive is negative. 2 times x is 2x. A negative times a negative is positive. 2 times 2, 2 times 4 is 8. Okay? Now, in the last problem we were finished because there were no like terms. In this problem here, we're not finished. We've got like terms. There's only 1x squared, so bring it down. But there are 2x terms, a negative 4 and a negative 2. So combine those, you'll get a negative 6. You owe me 4, you owe me 2, so now you owe me 6, negative 6. And then lastly, bring down your constant term, and we're finished. Not too bad, okay? Alright, number 47. Okay, notice the two parentheses are side by side, so we are multiplying. We're taking a binomial, a two-termer, times a trinomial, okay, a three-termer. So here we go, take your first term x and multiply it all the way through times everything. X times x squared, x cubed. A positive times a negative is negative. X times 2x would be 2x squared. Positive times a positive is positive. X times 6 is 6x. Now take your positive 9 and multiply it through, okay? Positive times a positive is positive. 9 times x squared, 9x squared. Positive times a negative is negative. 9 times 2 is 18. Positive times a positive is positive. 9 times 6 is 54. And there we go. Now simplify and we're finished. X cubed, I only see one of those, so bring it down. X squared, I see two terms. 1, 2, a negative 2 and a positive 9. When you combine those, you get a positive 7. X squared, cross those off. Now I see two x terms, a positive 6 and a negative 18. If you combine those, you get a negative 12. And then lastly, bring down your constant term. And there we go. There's your polynomial. Okay? Alright, let's continue on. Number 53. X minus 4 to the third power. Now we should understand by now, students, that means to write x minus 4 3 times. Okay? If you did this right here, watch. If you did this, you're wrong. If you put a 1 here and a 1 here and multiplied the 3 through and got 3 times 1 is 3. 3 times 1 is 3. So you would end up with this. 4 times 4 times 4 is 64. That's wrong. Do you know what, Mr. Eric? You taught us to do that. You told us when a power is raised to a power, you can multiply the exponents. I did teach you that, but I also told you there had to be one term on the inside parentheses 3 times. Now, if you had something like 2,981 times 1,210 times 592, and you did not have a calculator, well, you know what to do. You would first multiply these two numbers right here, and then whatever you would get, you get a number out here, then multiply that times the next number. Well, it's no different here, students. We're going to start with this group times this group and forget about this until we're done with the first multiplication part. And then we'll bring this down later. So we're going to take this group times this group, forget this right now, okay? X times x, x squared, x times negative 4, positive times the negative is negative, x times 4 is 4x. Now you have a negative 4x. Negative times a positive is negative. 4 times x is 4x. Negative times a negative is positive. 4 times 4 is 16. Now, let's combine our like terms. We have an x term and an x term. Negative 4 and negative 4. You owe me 4. You owe me 4 more. Now you owe me $8. Now, I multiplied these two binomials together and I got this. Okay? So you bring down this last parentheses. Now, students, if you write it like this, it looks like that you bring the x squared down and the 8x down and take the 16 and multiply it through. And that's not correct. Listen to me, guys. This entire expression right here equals this, and you're multiplying the entire thing times this. So you must put parentheses around this. There. Now we have a trinomial times a binomial. So pick up your x squared and multiply it through. Okay? Like that. X squared times x, x cubed. X squared times 4, positive 4x squared. Now take your negative 8x and multiply it through, okay? Watch your signs. Negative times a positive is negative 8x times x. 8x squared. Now negative times a positive is negative 8x times 4, 32x. Now take your 16 and multiply it through. 16 times x, positive times a positive, 16x. 16 times 4, positive times a positive, positive 64. And look at that. Now we're really close to, I think I've made a mistake here somewhere. Yes, right here. Sorry, students. X squared times x is x cubed. X squared times 4 is 4x squared. I apologize for that mistake. Alright, here we go. Now, let's combine our like terms. I only see 1x cubed. Bring that down. I see 2x squareds. And it looks like, boy, I hate that I made another mistake here, guys, but, it's looking like I did. Oh, yeah, this should be a wow. Okay. Well, yeehaw, as they say. Alright. Alright, this should be a negative 4, shouldn't it, guys? See this negative 4 right here? That should be a negative 4. Alright, very sorry. Here we go. X squared times x, x cubed. X squared times negative 4, negative 4x squared. Now take your negative 8x and multiply it through. Negative times a positive is negative 8x times x, 8x squared. Negative times a negative is positive. Negative 8 times negative 4, positive 32x. Now take your 16 and multiply it through. 16 times x, 16x. And 16 times negative 4, negative 64. Alright. I see only 1x cubed, so bring it down. I see 2x squared, it's negative 4. Negative 8. When you combine a negative 4 and a negative 8, you get a negative 12. Now combine your x terms, positive 32, positive 16, positive 48. Then bring down your negative 64. And there we go. Alright, there we go. Now, obviously. So guys, that's it for the homework help video. I hope this video makes sense. I apologize for the mistake I made earlier in this problem. But students, listen, make sure you're understanding this.